November 5th, 1955.
Why? I don't get what happened.
That was the day I invented time travel. I remember it vividly. I was standing on the edge of my toilet, hanging a clock. The porcelain was wet. I slipped, hit my head on the edge of the sink, and when I came to, I had a revelation, a vision, a picture in my head, a picture of this. This is what makes time travel possible. The flux capacitor.
So what do you know about flux?
Flux, actually the word flux means flow. This flow can be of a fluid or an energy that moves like a fluid, such as a magnetic field, an electric field. This can be used to describe fluid dynamics, heat transfer, and even mass transfer. Flux is generally a quantity, a scalar quantity that depicts the magnitude of the flow through a surface. This number can be either positive or negative. If it's positive, that means that flow is leaving the area, and the area can be called a source. If it's a negative number, then fluid is entering or flowing into the area, and it can be called a sink.
So what do you know about flux?
Flux passes through a Gaussian surface, and a Gaussian surface is a closed surface in a three-dimensional space through which flux of a vector field is calculated, and it's represented by the formula. It's represented by the Greek letter phi, represented by the formula electric field times the derivative of the area and the integral. And there are two types of surfaces that we learned about in class. There's a spherical surface, which is used when finding the electric field of a flux is produced by a point charge, in which there's a constant to that. It's represented by E naught. Don't have that on the board, but anyway, you just basically add cosine of 0, which essentially is 1. And then the other surface is a cylindrical surface, which is used when you're trying to you're trying to measure an infinitely long line of charge, and it's represented by the same formula, but instead you're adding the cosine of 90 onto the end of the formula. That's what I remember about Gaussian surfaces and flux.
So how is flux capacitor connected to this whole idea of time traveling? Well, to begin to understand that, we need to know what flux is. And flux is flow per unit area. It's found in two main fields, electromagnetism and transport phenomena. For the second one, there are multiple examples of such flux. One is heat transfer, another one is mass transfer, and fluid dynamics. An example of overall flux would be something like reverse current. So as water goes through a river, that's the same way that flux goes through a wire. There are multiple theorems addressed to flux. One is divergence theorem, another one is Stokes theorem. Both relate to problems that deal with currents and forces. And Stokes theorem is actually directly related to fluid dynamics. So why can't we explain, or why can't we make cars use the flux power then to run? As a matter of fact, some of the companies right now use flux power already to make their cars run. The electric cars, they work like normal cars, but normally half of it uses this battery that's run by so-called flux power. And so what about the time traveling part? Well, let's ask the main guy.
Oh, it requires something with a little more kick. Plutonium!
Plutonium. Wait a minute. Are you telling me that this sucker is nuclear?
Hey, keep rolling there. No, this sucker's electrical. But I need a nuclear reaction to generate the 1.21 gigawatts of electricity I need.
Doc, you don't just walk into a store and buy plutonium. Did you rip that off?
Of course, from a group of Libyan nationalists. They wanted me to build them a bomb. So I took their plutonium and in turn gave them a shiny bomb casing full of used pinball machine parts. Come on, let's get you a radiation suit. We must prepare to reload.